Today we're taking a deeper look at the rules of exponents. So your essential question is, how do I apply the rule of exponents? Your learning intention: I'm learning to simplify expressions and solve equations using the rules of exponents. You've got 2 warm-up questions. Can you pause the video and do them now? Well, I hope you tried. So we've got 2, and then we've got the exponent of 4 plus 2, so it will be 4 plus 2 for my exponent. Remember, if you're multiplying, you add the exponents. We've got x, and we've got 4 here, and we've got here, so it's 4 plus 8. And we've got y. If it's not there, it's understood to be 1. It's that imaginary 1, plus 3. And so we end up with 2 to the 6th, x to the 12th, and y to the 4th. But sometimes you need to figure out what 2 to the 6th power is. So that you've got 6 factors of 2. 2 raised to the 6th power is equal to 64. So this is 64, x to the 12th, y to the 4th. Okay, how about the next one? When you multiply, you add. When you divide, you subtract. So if I'm looking at 12 and 14, they both have a factor of 7 in them. I'll simplify that. 21 divided by 7 is 3. 14 divided by 7 is 2. I've got x to the 3 minus 1, y to the 9 minus 4, and z to the 1 minus 7. Okay, 3 halves. X to the 2nd, y to the 5th. But if you notice, I've got 7 down here, I've got 1 up here, so it's going to be z to the 6th, but it's going to be in your denominator. And this brings us to the other rules. Any base raised to the 0 power is 1. A to the 0 power is 1. This whole thing, it doesn't matter what's inside. It's raised to the 0 power, it is 1. We've got 2. It's not raised to the 0 power, times 1 times 1 times 1, which simply gives me 2. And I'm done. Okay, the power of a power rule. If you got A, B, and C, A raised to the B, and that quantity raised to the C is equal to A raised to the BC power. How does this work when you apply it? You're multiplying, so this is A to the 4 times 2, B to the 5 times 2, and C to the 1 times 2. If it's not there, it is understood to be 1. 4 to the 8th power, or A to the 8th power. I was thinking it was 4. A to the 8th power, B to the 10th power, and C to the 2nd power. On the next one, you notice that the 3 is outside of the parentheses, so it's not getting affected by that exponent of 3. This will be 2 to the 1 times 3 power, x to the 2 times 3 power, y, if it's not there, it's understood to be 1, 1 times 3 power, and z to the 3 times 3 power. So this is 3 times 2 to the 3rd, x to the 6th, y to the 3rd, z to the ninth. Okay, that is leaving it in exponential form. If they want it simplified further, the 2 to the third power is 8. 3 times 8 is 24. X to the sixth, y to the third, z to the ninth. So if the power to a power rule says that you multiply your exponents. So let's recap. When you multiply with like bases, you add the exponents. When you divide with like bases, you subtract the exponents. When you raise a power to a power, you multiply. This brings us to a negative exponent rule. You cannot have a negative exponent. The only time you use negative exponents is when you're using scientific notation. Any other time, for any a and b, which are elements of the real numbers, a raised to the negative b power means it's going to go to the denominator. If it's in the denominator, it goes to our numerator. This negative just kind of switches it back and forth between the denominator and the numerator. So 2 to the negative 3 is 1 over 2 to the third, which is 1 over 8 as a fraction. If we're looking at this will make it jump up. So this becomes a to the third times a to the eighth. And this is a to the 11th power. You add those exponents. Remember, it will flip that over the fraction bar, depending on if it's up above or down below. Okay, now, here are all the rules put together. Okay, so it shows you all the rules of exponents in a nice chart. Make sure you copy those into your rules that you can use on your test and your quizzes. So as we're looking at this is multiplication. So this is 2 to the 1 plus 1 power, m to the 2 plus 3 power. That gives us 2 squared, m to the fifth. I could take it one step further. 2 squared is 4, m to the fifth. For the next one, if you're thinking about this, we've got 2 r's up here, we've got 3 down in the denominator. They're going to cancel out except for the third one in your denominator. This will be 2 over r. If you're looking at it, it's 2r to the 2 minus 3, which is 2r to the negative 1, and that brings us back to our answer. Okay, the next one is pretty involved. You're still going to start off with 2 over 3 to the third. You've got x to the 4 minus 2, y to the negative 4 minus negative 3, z to the negative 3 minus 4. Okay, 2 over 3 times 3 times 3 is 27. Then we'll have x squared, y to the negative 4 minus negative 3 is negative 4 plus 3. That leaves negative 1. And z to the negative 7. Can't have negative exponents, so let's clean it up. 2x squared over 27, y to the first, z to the 7th, and we're done. Finally, for the last one, anything raised to the 0 power is 1. All that work, and now all it is 1. So how do you know what you're successful? You know you're successful when you can simplify expressions and solve equations using the rules of exponents. This is rules of exponents.